Before we start talking about how we can balance equations, I just want to make a little comparison. If you're trying to learn how to balance equations at the moment, you're probably doing GCSE science, and therefore you're probably also doing GCSE maths. So you know that this is called a quadratic equation. And you'll know that for a relatively simple equation like this one, some people will be able to look at that and say, I need two numbers that will add together to make 5 and multiply together to make 6. And therefore they'll be able to say, okay, this is going to be x plus 2, x plus 3. Now, not all of us can do that, but some people can. Then you get more complicated quadratic equations, and they start making you use this absolutely horrendous expression, which you can use to solve a quadratic equation. Now, the thing is, even with a straightforward equation like this one, this expression will work. And so the method we're going to use for balancing equations today, what I'm going to say is some people can just look at simple equations and just balance them in their head, particularly if they're the kind of person that can do these. But the method we're going to do today, while it takes a bit longer than just sort of feeling it out, it will always work and it will always get you an answer. So even if you're someone that finds balancing easy, it's worth learning how to do it because it will allow you to solve more complicated expressions. And if you're not someone who can do it just by looking, well, great, now you've got a method. So quite often, when a question asks you to balance an equation, part of the problem is that students don't understand why they need to balance it. So let's just talk about that quickly. There's a concept called conservation of mass, and what this means is that in a chemical reaction, atoms cannot be created or destroyed. They can only be moved around. So if I take a typical example of a chemical equation, what conservation of mass means is that whatever atoms I had at the start on my left-hand side of the equation in my reactants, I have to have the same number and the same type of atoms at the end on the right-hand side of my equation. The atoms can't just vanish into thin air. So that's one thing I need to understand. The other thing I need to understand is that these formulae, these symbol formulae that tell me what chemicals there are, they are fixed. So hydrogen is hydrogen, it goes around as H2, and I can't just decide that I want it to be H3. I can have more of them, or less of them, but I can't just change the formula. And then likewise, oxygen is O2, and water is H2O. And those formulae are fixed. So I can't change them. All I can change is how many of the different molecules I have. So, how are we actually going to do this practically? Our first step is that we need to count up how many atoms of each element there are on the left side of the equation and the right side of the equation. So I've got 2 hydrogens here and 2 oxygens here. I've got 2 hydrogens here, and I've got 1 oxygen here. My second step is that I need to pick which element I'm going to start with. Now here, it's quite straightforward, because hydrogen is currently balanced for the moment, and oxygen's not. You want to look for an element that only features once on both sides of the equation. So if you've got an element that appears twice, save that one to the end. It will make your life easier. My third step is that for the element I've picked, I need to work out what the lowest common multiple is. So if your maths is a little bit shaky, what we mean is we want a number that 2 will go into and 1 will go into. Now again, we've got quite an easy example here. So obviously the smallest number that 2 and 1 will go into is 2. So I'm just going to write that here in the middle. My fourth step is about figuring out what the coefficients will be. So coefficients are the big numbers that go in front of these molecules to say how many of them there are. So I'm aiming to have 2 atoms of oxygen on both sides. So given that I've already got a molecule that contains 2 atoms here, I don't actually need to do anything to this side of the equation. Now, if you wanted to in a GCSE exam write a 1 there, you wouldn't be marked down for it, but usually we just don't bother. Chemists are lazy, we never bother writing 1. So there's my 1 oxygen molecule. over on this side, in order to make there be 2 atoms of oxygen on the left side of my equation, I need to multiply this by 2. So I'm going to write this 2 in front of the molecule. That's my coefficient. And so what this now means is that instead of just having 1 water molecule, I've got 2 water molecules. So you can see I've now got 2 oxygens to go with my 2 oxygens, but I've also got 4 hydrogens. I'll just move those out of the way. So this is where we come to our next step, which is we have to do the whole thing all over again. And this is the bit where people fall down because they forget to recount things. So my first thing was counting. So I've still got 2 hydrogen here, I haven't touched it. I've still got 2 oxygen here, I haven't touched it. I've now got 4 hydrogen and 2 oxygens. Oops. So, second step, figure out what needs fixing. So my oxygen is now fixed, but now my hydrogen needs fixing. My third step, hidden down here, lowest common multiple. So I need a number that 2 goes into and 4 goes into. So again, this one's quite straightforward. We're aiming for 4. Fourth step, work out what coefficients I need to use to make the magic happen. So here I've already got 4 hydrogen atoms, so I don't need to do anything. Here I need twice as many, times 2. So this times 2 goes in front. That's the only place I'm allowed to write numbers. And then remember, my fifth step is repeat. So count it all up again. I've now got 4 hydrogen to go with my 2 oxygen and 4 hydrogen to go with my 2 oxygen. We are balanced. If you think you've got it, then great. If not, I'm going to look at a few more examples. Here we've got the Haber process, the production of ammonia, which you'll know a bit more about if you're doing triple science, and hopefully you recognise this double-headed arrow in the middle here, which shows me that it is a reversible reaction. So we're going to go through our 5 steps just like we did before. Step 1 was to count up the atoms. I've got 2 atoms of nitrogen here, and I've got 2 atoms of hydrogen here. And then over on the right-hand side of the equation in my products, I've only got 1 atom of nitrogen and 3 atoms of hydrogen. My second step was to pick which element I'm going to start with. Now, I would suggest if you've got numbers on either side where one is half of the other, leave that one to the end. Basically, that's easy, so don't worry about it. This is going to complicate things more. So we're going to start here. So my third step was I needed a lowest common multiple for 2 and 3, a number that 2 and 3 will both go into. So I'm going to go for 6. To turn 2 into 6, to make sure that I have got 6 atoms on this left-hand side made out of my little hydrogen molecules, which each had 2 atoms in them, I'm going to need 3 of those hydrogen molecules. So I put a big 3 there. To make sure I've got 6 on this side, I'm going to need 2 of this ammonia molecule, because 2 times 3 is 6. So that 2 goes there. And then my fifth step was to repeat it, starting with counting. So I've still got 2 nitrogen here. I've now got 6 hydrogen here. I've now got 2 nitrogen here. And I've got 6 hydrogen here. So that entire equation is balanced. Time for another one. So, just like before, I'm going to start off by counting up my elements, only this time I've got 3 of them to worry about. So, I have got 1 titanium, 4 chlorine, 1 magnesium, and then over here, I've got 1 titanium, 2 chlorine, and 1 magnesium. So, my second step was about picking which element I'm going to start with. Titanium is balanced, chlorine's not, magnesium's balanced. So obviously, I've got to start with chlorine. Third step, what's the lowest common multiple? What is the smallest number that 2 and 4 go into? Well, it's 4. So, on this side, I don't need to do anything. I've already got 4 atoms, which is what I'm aiming for, on the left-hand side. On the right-hand side, I'm going to need to double it. 2 times 2 is 4. And so this 2, it's going to be a coefficient. It's going to go in front of my magnesium chloride. So then, remember, your step 5, we've got to repeat the process because although we've balanced the chlorine, we've now thrown everything else out. So everything on the left side is still the same. I haven't added any coefficients. On the right side, still 1 atom of titanium. I've now got 4 atoms of chlorine, but I've also got 2 atoms of magnesium. So we need to go back through the process again. So I'm going to pick, and obviously I'm going to pick magnesium because that's the one that's now not right. Lowest common multiple of 1 and 2 is 2. So on this side, I don't need to do anything. On this side, I need to double it. So I put the 2 in front of the magnesium. And then I am back to repeating it. So back to step 1, counting them up. So I've still got 1 titanium, 4 chlorine. I've now got 2 magnesium to go with my 1 titanium, 4 chlorine, 2 magnesium. I'm balanced. Let's do another example. So now we've complicated things slightly because now I've got oxygen and oxygen, and it's always harder to balance things that have the same element twice. So you definitely want to leave that element till the end. Make that element be the last thing that you touch because otherwise it's just going to get complicated. So we start off and we count. 3 carbons, 8 hydrogens, 2 oxygens. And over on this side, what I'm going to do is I'm going to say 1 carbon, 2 hydrogens, and I'm going to write the oxygen as 2 plus 1. And the reason I do that is that I have a really bad habit of forgetting that an element is in 2 different compounds. And then when I try and do the counting later, it all goes wrong. So if I write it like this, whenever I go back to recount, it just serves as a little memory that I need to make sure I'm looking at both compounds. And I just find that really helpful. So I've done my counting, and I now need to do picking my element. So we've said we're not going to do oxygen because oxygen is going to be a pain and it'll just complicate things. So I've got my option of either doing the hydrogen or doing the carbon. Let's start with the carbon because it's at the top. So, lowest common multiple is 3. This side doesn't need to do anything. This side, to get from 1 to 3, I times by 3. This 3 is going to be the coefficient. It goes in front of the compound that has carbon in it. Goes there. So I now need to recount. So on this side, I've changed my carbon. That's now 3. Great. I've also changed my oxygen. So I've got 3 lots of 2. 1, 2, 3, 4, 5, 6. So this is 6. And you see what I mean here. It will be really easy for me to cross out 3 and write 6 and then forget. But actually we've got 7 versus 2, not 6 versus 2. So I'm still going to leave my oxygen alone. Next up, I'm going to go for hydrogen. So I've got 8 and 2. Lowest common multiple of 8 and 2 is 8. This side we don't need to touch. This side, to get from 2, so 2 atoms in each water molecule, 8 atoms in total, I need to times by 4. So I'm going to put a nice 4 up the front there. And now I'm going to recount. So I've changed this to 8, which is great, but I've changed this to 4. So now I've got 10 in total. So finally, I can tackle my oxygen. Lowest common multiple of 2 and 10 is 10. So this side, we're not doing anything. This side, we're timesing by 5. So we're going to put 5 in front of there. And just to be on the safe side, let's recount. So we have got 3 carbon, 8 hydrogen, 10 oxygen, 3 carbon, 6 oxygen, plus 4 oxygen, so 10 in total, and 8 hydrogen. One more for good luck. Now, the reason I picked this one is that it involves brackets, and quite often people aren't very sure about what the brackets actually mean when they're looking at symbols. So just in the same way that, say, this 3 here only applies to the oxygen. It doesn't apply to the nitrogen or the potassium, it just applies to the thing it's next to. The 2 here is next to the bracket, so it applies to the bracket. It means there are 2 of the bracket. So if I wanted to, I could rewrite this as PbNO3NO3. So in total, this compound has 6 atoms of oxygen for every 1 atom of lead. Anyway, we're going to go for our normal steps. So we start off and we're going to count up. 1 potassium, 1 iodine, 1 lead, 2 nitrogen, 6 oxygen. And over on this side, 1 potassium, 2 iodine, 1 lead, 1 nitrogen, 3 oxygen. So we've got lots and lots that we could pick from here, and it's really just personal preference what we want to go for in terms of picking our element so that we can work out the lowest common multiple. So I'm just going to work from the top, and I'm going to start with iodine. So 1 and 2, lowest common multiple is 2. So this one we don't have to do anything. This one we have to times by 2. So the 2 goes there in front of potassium iodide. 5th step, repeat it. So I need to start off by counting everything again. So I've now got 2 potassium and 2 iodine. Okay, so in which case, let's go back to potassium and sort this out. Same numbers, so same idea. Lowest common multiple is 2. To get from 2 to 2, I don't need to do anything at all. To get from 1 to 2, I times by 2. So I'm going to put a 2 here in front of potassium nitrate. So now I need to count again. So I've now got 2 potassium, 2 nitrogen, 6 oxygen. So I'm now 2 for 2, 2 for 2, 1 for 1, 2 for 2, 6 for 6. I'm balanced.